Okay, guys. Um, New unit. A unit called transformations is what we're about to begin. And what I want you to do is, if you haven't already printed off your notes for 9-1 and 9-2 for the week, go do that. Pause the video, go print them off. Then I want you to come back and I want you to keep the video paused. I want you to write down these definitions. Okay? Go. All right. Now that I think you've paused the video and gone and done that, let's talk. Okay? We are starting a new unit called transformations. Okay? So the unit is just that. It's just the word is transformations. Okay? Transformations. And in mathematics, it just means to change. Okay? A transformation is a function or a mapping, that's the key word for us, a mapping, that results in a change in the position, the shape, or the size of the figure. Okay? Today we're going to talk about the first type of transformations, the easiest type of transformations called translations. Translations. It just means to move. So we're going to be moving things left, right, up, and down. Preimage. The original figure is the preimage. It's what comes first. It's like when you go to the theater to watch a movie, which we would love to be able to go do again right now. But if you go to the theater, what do you see first? You see the previews, okay, of coming attractions. So what comes first is called the preimage. What comes second is called the image. The result of a transformation is the image, okay? If we perform a transformation, which we're going to learn them all, and this is only one of them, translations. If we perform a transformation or a combination of transformations on an object, and the object or the shape doesn't change, in other words, it was a hexagon to begin with, it's a hexagon when it's moved, and its side lengths and angles are all the same, any transformation that preserves distance and angle measure is a rigid motion. It's a rigid transformation. It means the shape doesn't change, okay? So, homework on Math Excel this week. Some of you are going to find it very, very easy, trivially easy almost. Be careful, because you don't want to think it's so easy that you don't pay attention to the rules. So, which transformation appears to be a rigid motion or transformation? Here's a preimage, this little square. Here's the image, big square. It got bigger. So no, it's not rigid. Here's the first kite, and it flipped over. Okay, that's all the kite did, but it's still the same shape. So the preimage and the image have the same lengths, side lengths are the same, and the same corresponding angles are all the same. Yes, the two shapes, images are the same with different locations. 3, preimage and image. Yes, same shape. If you take this guy and you flip him over and then move him, what you can see is he's flipped. So there's a flip, okay? And then this corner flips over, but then it moves to here, and then it moves up to there. And you would find that this one moves and moves, yeah. So, okay. A transformation maps every point of a figure onto its image and may be described with arrow notation. Arrow, kind of like I did over here. That's supposed to be an arrow. Prime notation, tick mark, okay? Sometimes used to identify image points. In the diagram below, K prime, this reads K prime, is the image of K. So here's K, right here. Let's do a different color. Here's K, and here's K prime, okay? Couple things going on here, though. Notice these dashed lines have arrowheads on them. See that? So this point is over to here, this point's been moved over here, and this point's been moved over here. So triangle JKQ is the pre-image, and the image is triangle J prime, K prime, Q prime. And it reads just like that. So we say triangle JKQ, this one maps onto this one. And the reason it maps is because it didn't change size and shape. Okay? Notice that you list corresponding points of the pre-image and the image in the same order as you do corresponding points of congruent or similar figures. Okay? So in the diagram, triangle NID, this triangle, maps onto triangle SUP. Okay? What are the images of angle I, and point D? Point D. Oh, this is not an angle. I pre-wrote some stuff, so I want to say point D. So angle I maps over to here. Okay? So it goes with angle U. Now, since we are not using the same letters, we do not need the prime letter, the prime. So we don't need this guy up here, okay? Oh, I didn't realize you can't see. I had an angle marker here. It's point D. So I pre-wrote some stuff so we can move through this a little quicker because I'm not trying not to make your videos super long. Point D is going to map to point P, and point N is going to map to point S. How did I know that? Well, because it told me N goes with S, I goes with U, and D goes with P. Okay? So, what are the pairs of corresponding... Oh, point D, sorry. Point D goes with point P. Okay? Now, side NI goes with... So I've got a picture, but I've also got letters. NI goes with SU. ID goes with UP. And DN goes with PS. That's all there is to it. You're going to get questions like this in your homework tonight. Okay? So let's move on to page 2. Page 2. Key concept, translation. A translation is a transformation that maps all points of a figure the same distance in the same direction. You write the translation that maps triangle ABC onto triangle A prime, B prime, C prime as T for translation of ABC equals this one. A translation is a rigid motion with the following properties. If translation of triangle ABC is equal to triangle A prime, B prime, C prime, then AA prime is equal to BB prime is equal to CC prime. And AB is equal to A prime, B prime. And these are lengths. These are not segments, okay? I did segments on the other side, but because it asked me for corresponding sides. This AB represents the length AB is the same as the length A prime, B prime. That's what this reads. The length BC is congruent or equal to the length B prime, C prime. And the length AC is equal to A prime, C prime. Measure of angle A is equal to measure of angle A prime. Measure of angle B is equal to measure of angle B prime. Measure of angle C is equal to measure of angle C prime. This is a rigid motion. Translations are always rigid motions. Translations will not change the size or the shape of the polygon pre-image that you are starting with. All right, what else are we doing in homework tonight? Okay. Example 3. Apply the following transformation. X comma y, for every point x, y, we want to perform this translation. X take away 2 or x minus 2. This says each x value moves, well, if I subtract 2, which way is it going? How far is it going? 2 units to the left. Okay? Remember, when we add and subtract, we're going left and right. If we're subtracting, it's left. If we're adding, it's right. y minus 5, each y value moves 5 units up. Oh, dadgummit. My bad. Down. I don't know why, but I wanted to say up. But it's down because it's minus 5, right? Okay, so here's all I'm going to do. I made a little table. The point that I'm starting with, R, PQ, and I've already counted them out. Negative 1, 1, 2, 3, that's R. 3, 3 is P. No, it isn't. 3, 1 is P. 2, 1 is P. Oh, ha. I wrote down the wrong points in the wrong place. Okay, I'm glad I'm checking. 1, 2, 1. P is 2, 1. And Q is then going to be 3, 3. So here's all we're going to do. We're going to take this point and we're going to subtract 2 from it. So what I'm going to say, R prime, is going to be negative 1, this guy right here, take away 2, comma, this guy right here, 3, take away 5. So what is negative 1, negative 2? It's negative 3, and this is negative 2. This is my new point for R prime. Do the same thing for P, but it's going to be P prime, okay? It's going to be P prime, and it's 2 take away 2, and 1 take away 5, okay? If you notice, these two are the same, and these two are the same. They're not going to change. Guess what it's going to be right here? 3 minus 2 and 3 minus 5. Okay? So notice that these points are the same as these points. It's the same as these points. Now, I got negative 3, negative 2 here. I get 2 take away 2 is 0. And 1 take away 5 is negative 4. 3 take away 2 is 1. And 3 take away 5 is negative 2. If I wanted to, I could plot them. I don't know that they'll fit on this graph. I'm certain they won't, because I would go 1, 2, 3, 1, 2. So negative 3, 2 is going to be like right about there for R prime. So by the way, this said move it 2 and down. So that guy's here, which means this guy's going to be even farther, right? 0, 1, 2, 3, 4. I'm kind of guesstimating. That's going to be P prime. And this one's going to be 1, negative 2. So it's going to look like this. And remember, I don't have a grid here, so I'm kind of guesstimating. It looks a little bit longer, fatter, whatever, but it moved this way, and then it moved that way. Okay? That's all there are to translations. Remember, transformations means all of them, and you've only learned one so far. I'm going to do another video in a minute that's going to be reflections. So, what is the rule that describes the translation that maps polygon PQRS onto polygon P prime, Q prime, R prime, S prime? Well, here's what you do. When you want to find a mapping, all you're going to do is you're going to take P, which is, I counted over 1, 2, 3, 1, 2, 3, 4. It was negative 3, 4. Then I found P prime. And I counted over 1, 2, 3, 4, 5, up 2, 5, 2. So here's all I did. This point maps onto that point. So I took the x values. See the x value? I took negative 3 plus what value of x equals 5 equals that one. I'm working with these two. Well, if I do the math, plus 3, x equal 8. Okay? What that means is I'm going to take any point x, y, and it's going to map onto, and I'm going to put prime here. It's going to be x plus 8, because it's going to go right 8. Okay? So if I count 1, 2, 3, 4, 5, 6, 7, 8. Oh, look at that. Now, this one was 4 to 2. So 4 plus some number y is equal to 2. Subtract 4, subtract 4. When I do that, I get y equals negative 2. Y minus 2. And look, if we go and we trace our original point P, and we count over to here and down to here. What we end up getting is this is a +8 and this is a -2. +8 and -2. That's our rule, guys. And that's how hard it is. Not. If you're watching the video, hopefully you're going, yes, sir, Mr. Sterling, that's easy. So, composition of transformations. Composition, to compose, to put things together. This is a combination of 2 or more transformations. Right now, we only know 1, but in just a few minutes, you're going to learn, well, tomorrow, you're going to learn about reflections. Okay, that's it for today. I'm going to make the video for tomorrow's lesson. Hope you're enjoying your day off, because this is my day off.